In this video, we're going to describe how to draw Lewis structures. Now, Lewis structures are a huge component to chemistry, as they allow us to draw the attachment of atoms to each other in molecules, specifically covalent molecules. Lewis structures show the outermost electrons and how they are involved in bonding. Here we can see two Lewis structures, one for hydrogen and one for chlorine. And what we get from both of these is that there's a single attachment or a single bond between both atoms. Now in hydrogen's case, all the electrons in hydrogen are shown, and those are represented by the line between the two hydrogen atoms. Chlorine, you can see, has a single line between the two atoms, but also a series of dots, or known as lone pairs, that is, sets of two electrons surrounding each chlorine atom. And these electrons come from the outermost electrons, or the valence electrons, found on the chlorine atom. Now, in order to write a Lewis structure, the first thing you need to do is find how many valence electrons there are. For something like PCl3, phosphorus has 5 valence electrons. That is, if you count from phosphorus on the periodic table from left to right, you'll find phosphorus is the 5th element moving from left to right, so there are 5 valence electrons. Likewise, we have 3 chlorine atoms, and chlorine being the 7th element moving from left to right, we have 7 valence electrons. So in PCl3, we've got 26 electrons to find a combination in which all atoms think that they have 8 electrons around them. That is, each atom wants to become like a noble gas, surrounded by 8 electrons in one way, shape, or form. Now, if we have a polyatomic ion, then the negative charge means that there are more electrons, so we would have to add more electrons to this total. Likewise, if there was a cation present, we would have to subtract the missing electron from the total. We'll see more about these when we actually do some practice problems later on in the chapter. Now, when picking out an atom to draw, we first have to ask ourselves, well, what's the central atom going to be? The central atom is going to be the least electronegative element present, with the exception of hydrogen. Hydrogen can never be a central atom, and we'll see for reasons why later. After that, we connect each atom to the central atom by using a line. Each line represents 2 electrons. So here we've got 3 lines, so we've used 6 electrons total of our 26. That means we have 20 electrons left to place. Well, when we start assigning the remaining electrons, the most electronegative elements get their electrons first. That is, chlorine is going to pick up its electrons. So we place our lone pairs surrounding the chlorine atom before we're going to start putting them on the phosphorus. Now, the first thing we need to remember is that only 8 electrons are desired by each atom. And since the chlorines have 2 electrons already in the form of the bond, each chlorine is going to get 6 additional electrons for our grand total of 8. That is, lines count as 2 electrons and dots count as 1. So we can see chlorine now has 8 electrons around it. We've got 3 chlorines, each one with 6 additional electrons, so we've used 18 of our 20 remaining electrons. Now we have to place the last 2 electrons. Well, the only place we can put the electrons is on the phosphorus. So we then assign the remaining electron to the central atom. Now, sometimes we run out of electrons before we can assign our central atom. If this is the case, we still need to find a way of getting 8 electrons around each atom, but we're going to have to take some lone pairs and convert them into bonds. So you can have more than one line between any 2 elements. And again, if this seems a little confusing at this point, well, we're going to practice some, so we'll get a feel for how this actually plays out in a little bit. So how do you know you've drawn the right Lewis structure? Well, we have to use something known as formal charge in order to determine whether the structure we've drawn is correct. So each atom in our structure is going to have a calculated formal charge. So the way we calculate formal charge is by taking the number of valence electrons we have and subtracting that from the sum of the number of dots each atom or each element has, plus the number of bonds we have. So we can see in two different structures here. One case we have a formal charge of 0 on oxygen, and another case we have two formal charges, -1 and +1. The best Lewis structure is the structure that has the fewest atoms with a formal charge. In this case, the carbon dioxide structure on the left is the best Lewis structure and the correct Lewis structure because it has the greatest number of atoms with no formal charge.